Now, let's tidy up our project and create a blueprints folder where we'll keep all of our framework for creating blueprints. Personally, I like to color code folders to make navigation easier, but it's up to individual preference. You can leave it as it is if you prefer. Move the character blueprint to the blueprints folder since we'll be using it. Also, move the inputs to the content folder. Similarly, move the maps to the content folder. You may encounter a warning message, but you can ignore it. To fix the references, right-click on the content folder and choose the Fix Up Redirectors option. It's good practice to fix references whenever you move files to prevent any issues that may break your project. Throughout the series, you'll notice me fixing references frequently. Delete any empty folders and remove the third-person game mode since we'll be creating our own. Make sure to remove its reference from the map world settings and save the changes. I'm using folder coloring to make them more noticeable. The level prototyping folder won't be used much, if at all, so I'll gray it out. Now, let's create a game instance. It's a blueprint class that is created at the beginning of the game launch and persists until the game is shut down. It's a good class to store data that we may need throughout the game. Let's name it BP_GameInstance. Additionally, let's add our own game mode and name it BP_MenuGameMode. Remember to save the changes once you have created these blueprints. Now it's time to create our first map. Since we're building a multiplayer game, we need a login level where our game starts. In the navigation bar, select New Level and use a basic template. Next, delete the plane shape that is automatically added and add our own shape to the level. At the top bar, select the quick icon and type plane to search for a plane-shaped mesh. Add it to the scene and in the Details panel, increase its size on the X and Y axis. Rotate the plane on the Y axis by 90 degrees by selecting it and pressing the E key. Now let's add a text render actor since I'm not friend with Blender to create a mesh. It may not look as good, but it will suffice for our example project. Adjust the text render actor to be close to the plane, but not too close. Rotate it 180 degrees so that the text is readable from the front. Rename the text render actor to our project name, EIK Example, and make it slightly bigger. You can experiment with the settings, but this size works for me. Make text color red or any other color you like. Adjust text to be in middle of plane. Next, add a cinema camera actor to our viewport. Adjust its position so that our project name is visible in its view. The smaller window that shows the camera view when it's selected makes it easier to make adjustments. Once we have it perfectly adjusted, select the red gizmo that represents the X-axis, hold the Alt key, and drag it along the X-axis. This creates a duplicate of the camera. Drag the duplicated camera as far as desired. Our level will start from this camera and gradually move to our first camera. But before we proceed, let's save our level to avoid losing our hard work if anything goes wrong. Name the map appropriately as Login Map. Now, how do we achieve camera movement? First, let's open the level blueprint. We can delete the tick event. Right-click and search for the Get Player Controller node. Drag the return value from this node and search for the Set View Target with Blend node. The controller class manages camera view. I will turn off auto formatting from Blueprint Assist and manually format the blueprint. Connect the View Target node to the Begin Play node to trigger it as soon as the map loads for the player. Now we need to add our second camera that we added to the level blueprint. To do so, go to the viewport, select it, and its reference will be added to the available actions in the level blueprint. Make sure to select the second camera as we want the player's view to start from it. Set our camera reference as the new view target by connecting the pins. To save time typing, we can copy and paste the view target node. Connect the player controller as the target and connect both nodes together. Set the blend target to 3 seconds, which determines how much time we want the camera view to switch to another and go back to the first camera. Add first camera reference by doing as we did with other camera and connect it as the new view for the second view target node. After making the desired changes in the blueprint, don't forget to compile and save it. It's important to do this regularly. Let's set the BP_menu game mode as our default game mode and set the default pawn as BP_third-person character. We'll set other options to our own created ones as needed. Next, set our login map as the starting editor map and the default game map. Also, set the game instance to the one we created. If you skip this step, you might get stuck in the next part of the video. Now, let's play our level. Did you see that? Let's remove the player's start point for it to not spawn our character. It seems like everything is good. Okay, let's save our progress and go grab some goodies from Epic's Made project. This is the UI Material Lab project that contains a ton of materials and material functions. We will use those assets to create our own UI. If Epic made it, it usually means that you can use it with Unreal Engine projects with ease. So go ahead and get it. It will be added to your library's vault, and from there, you can create that project. I already have it created, so I'll just open it. This Epic project contains a lot of UI examples made with materials. If you play the main map, you can see examples of the uses of materials and their functions within this project. It includes transformation functions, gradients, time-based effects, masks, patterns, distortions, and utilities, as well as application examples. For people familiar with materials, this project is a treasure chest of example applications for materials in UI elements. We will transfer some of the applications from this project to ours. I won't be redesigning them, but you can if you want. I just wanted to showcase this cool sample project that you can use to copy some UI applications. For our EIK example, we will transfer the sci-fi game menu buttons, progress bars, stat indicators, object fills, and screen panels. For now, we will focus on using the menu buttons, but later we might use the rest. To find what we need, I'll open the main widget blueprint of this project and navigate to the Applications widget. Now, we will look for the materials used to create those buttons. Here are all the material instances used in the application examples. Now, let's start transferring what we need for our project. We'll grab the buttons, borders, stat fills, objective fills, and progress bars. I think that's mostly what we need for now, but we can always return later if necessary. With everything we want selected, right-click on any selection, navigate to Asset Actions, and select the Migrate option. This will migrate all the related assets for our selected material instances. Locate your project's content folder and select it as the migration destination. We can close the UI Labs project now, but we're not done adding free goodies to our project yet. Buttons need to have clicking sounds, right? Fortunately, there is a free sound effects asset pack that we can add directly to our project. Since it's an assets pack, it can be added directly. Links to the assets will be in description. I will create a third-party content folder to keep non-Epic content organized. Although later, while reading the sound pack description, I found out that it can be used for any purpose, platform, or project. I like tidying up projects' content, so I will tidy up imported materials. The material function folder seems alright to move as it is to our UI asset folder. As for the other materials, I will restructure them according to my preferred organization. The textures folder can be moved to UI folder as is. We create folders in the UI directory for material masters and material instances. Let's move the assets that start with M for materials to the masters folder, and we can move the material instances folder to the UI folder. Now, we can delete the UI Material Lab folder. Before we dive into creating styles for our common UI, let's quickly add fonts. I grabbed the Montserrat fonts from the Google Fonts website. You can skip this step or find fonts of your liking, or use the default ones provided with the engine. Now, finally, we can start creating common UI styles as data assets. Create a Styles folder within the UI folder, and navigate to Blueprint Creation and search for Style in all classes. We will create a common border style and name it border style _ comment. We will proceed to do the same for button and text styles. These styles are data assets that will represent our modular styles for borders, buttons, and texts. We will use them to maintain a common style across our UI. Save our created styles. Now we can create our common text style. This is a data asset, so we don't need a graph and can just edit the properties of the style asset. Select the desired text font, text size, and any other parameters. I will stick with those for now for the common text style. For the common border, we will create a generally used border style similar to what YouTubers who make Unreal tutorials use. We will use a gray tint with lowered alpha. We will work on creating our imported border at a later time. Creating the button style will require more options and a bit more work. As you can see, it may seem overwhelming, but fear not, it's not as scary as it looks. Let's set the normal text style for our common text style. Do the same for the hovered style, selected style, and disabled style. For the press sound, I found backclick 04 to my liking, and for the hovered sound, backclick 01 works well, but you can set the ones you like. Don't forget to compile and save frequently. Let's duplicate the material instance of the button and add hovered to its name and rename button 3 to unhovered. Open it and change the value of hovered from 1 to 0. Now we have two instances of our button. Material instances can be changed at runtime, but this is not an advanced tutorial on materials. Now we can set the base look of our button. I made a mistake by making it hovered for the base look. Make sure you made it unhovered. For the normal hovered state, select our hovered material instance. For the normal press state, also select the hovered material. Our common button is now complete. Let's create our login blueprint widget. Let's make a folder for all our widget blueprints named widgets. Widgets are a class to design game UI. Now open the content creation menu inside widgets folder and navigate to user interface. Select widget blueprint and choose common user widget as the parent class. Name it WB_login and open it. Let's search and add an overlay to our widget hierarchy. One thing I forgot is to set our default editor styles in project settings, so let's do it now. Find Common UI Editor section, and for each selection, just select the style we created. Now we don't have the common button option in our palette. We need to create a modular button widget that we can reuse as our button. Create a modular folder in the widgets folder for our reusable modular widgets. In the content creation menu for widget blueprints, search for common button base in all classes. Name it WB_common button. Open it and add an overlay to see our button. But it is not our button, so select the top selection in the hierarchy named WB_common button and set our button style in the style property. And here it is. Select the desired screen ratio, and well, it looks button disappeared because I forgot to set the desired width and height in the button style. Let's set the width to 500 and the height to 60. Now our button is in full glory and looking pretty good. Our button needs text, so let's add our common text to our button. In Palette menu, search for common text and add it to overlay. For the alignment in the text detail panel, choose center alignment for both horizontal and vertical. To make the text customizable when we add this button to other widgets, we need to make the text a variable. Name it common button text. Compile and open widget graph. Drag the common button text variable into the event graph and select the set text function. Make sure it's not the tooltip text, but the regular text. Copy and paste this node and connect both to the event pre-construct and construct events. Drag the text pin out and select promote to variable and name it button text. Compile so we can set its default value to button text. Connect the button text variable to both nodes for setting the text. Duplicating the set text for both constructs will let us see the change button name in both the editor and the game. Also, press the eye icon to make this variable editable and set expose on spawn to true. Now we have our modular button that we can reuse for our UI. Now we can add our button to our login widget. Search for it and drag it onto our overlay. Make sure to choose WB Common Button, not just Button. As it's not a canvas panel, we'll cover that some other time. To set the desired placement for the button, use alignment and padding. In the meantime, let's name our button Login. For the bottom padding value, set it to 250 or your desired value. Now let's add our login widget to the login map. Oh my, what was that? It seems our third-person character wants to spawn even without a spawn point added. However, we still want it to spawn on our menu map. So, for a quick fix, let's create a login game mode that won't have a default pawn to spawn. After creating login game mode, open it and set the default pawn to none. And in the login map's world settings, set the login game mode as its overridden game mode. Now, nothing will spawn. Now we need to show and create functionality for our button. There are various ways to do it, but let's do it in the game instance. First, right-click in Game Instance Event Graph and add an init event. This event triggers when the game instance initializes, which is at the start of the game. Drag of init event pin and search for the Create Widget node to add it to our graph. In Class Selection setting, add our created login widget blueprint. Drag from Return Value pin and search for Add to Viewport. Let's play our login map. However, nothing happens. This is because the game instance is one of the first classes to be initialized when the game starts. To fix this, let's add a small delay before we create our widget. Now, we have our login menu. It's nothing spectacular, but it will do for now. Our on-hovered style works, and we have UI sound. Looks good. However, clicking on the button won't produce anything because we haven't tied the button click to any logic. Additionally, I noticed that my mouse disappeared when clicking around. This is because by default, our input mode is set to game and UI. To set it to UI only, we need to get the player controller from the return value of the game instance and search for the Set Input Mode function. Then, select the UI only node. We can add the widget in focus as the login widget. Now we have our input mode set to UI only, but where's the mouse? Well, by default, it is set to be invisible. So, let's get the player controller from the game instance, search for the Set Show Mouse Cursor function, and set its value to true. Now we have our mouse cursor, and clicking on anything outside our button won't make the mouse disappear into the game void. Great, but our button still does nothing. So, let's finally make it log us into EOS. Go to our login widget, select the button in the hierarchy, and in the detail panel, scroll all the way down to the events section. Click on the On button base clicked event. We can delete the other events. Now, we could do our login logic here in the widget. But let's say we need to have the product user ID value available to us. We will need this widget to exist throughout our game or transfer this variable to another place. If you have been following this tutorial closely, you might remember that the game instance class is created at the start of the game and persists throughout the game. So, let's create the login logic in the game instance. To do that, we will create a new custom event and name it Login to EOS. Drag off its pin and add the login using EIK node. We have a lot of login methods to choose from, but for now, we will focus on the account portal. To call this event from the login widget, we need to get the game instance. Typically, You would see tutorial creators just cast to the game instance that we created. But we will do it smarter and create a blueprint interface. It's not painful, and the sooner you learn about interfaces, the better developer you will be. I will add a link to a short video that quickly explains how blueprint interfaces work. For now, just create an interfaces folder in our blueprint folder, and in the content creation menu, choose blueprints and select blueprint interface. Name it BPI_game instance since it is the one that will be sending messages with our interface. In our created interface, we need to create a function named login to EOS. In our game instance blueprint, go to the class settings and add the interface we just created. To implement the function from the interface, double-click it in the Interface tab. It will be created as an event in our graph as it has no outputs. Let's replace our general event with our interface event. In our login widget, we can now call this event directly from the getGameInstance function and have no need to cast it. In the login using EIK node, we can ignore the display name and token inputs as they are used for other login methods. Drag the product user ID and search for the print string node. We want to print it to our screen after a successful login to have confirmation of our login. Let's copy the print string node to use for the on-fail event as well. However, let's make the on-success print green and last 1 second longer. And for the on-fail event, let's print an error message and make the message color red. We can drag colors to save them for fast use. We can even name them. Now, after a successful login, let's open our menu level. We can use the Open Level by Name or the Open Level by Reference node. I will use the Open Level by Reference node, but we don't have a menu map yet. So let's go to the Maps folder and create one. Duplicate the login map and name it Menu Map. Let's open it and make the necessary changes. First, let's change the shown text to Menu. Select the EIK example text and replace it with Menu. We can delete the second camera as we don't need it. The warning message appears because we had a camera reference inside our level blueprint when we duplicated the level and all its logic. Let's delete the blend for the second camera and keep it for the first one. Change the blend time to 0 so that it would be instantaneous. Compile and save. Now, let's move our only remaining camera to create a menu scene. Click on the plane and select the red gizmo. While holding Alt, drag it out. Now we have a second plane. Press R to rotate it along the green gizmo by -90 degrees. Lower the plane so it can be our floor. Seems good. Let's drag our third-person blueprint into our scene to have a visual reference for where to put our character spawn point. Rotate it 180 degrees towards our camera. It seems I picked a good spot. Now add a basic cube to be our character pedestal. We can select a material for it. We're going with a red theme, so look for red. Manage the character and pedestal placement as you wish. By clicking on the scene camera, you can check its view in the smaller corner to see how the scene will look. After you're happy with the placement, save it. Now, as you can see, if we play straight from the menu map, we get our login widget because we put our login menu in the game instance's initiation event. But first, let's fix the character being out of focus by selecting our camera and going to the camera focus settings. Select Manual Focus to focus on the pedestal. Now the character is in full focus. We need to replace the character blueprint with a player start. Add player start to the scene and delete the third-person blueprint from the level and rotate the player start by 180 degrees. The light blue arrow points in the direction where the character will be looking. Now, when playing it, nothing happens because we duplicated our map from the login map. So we need to remove the overridden login game mode from the world settings. Everything will work great now. Let's test our game functionality. Do all the dots connect? Open login map, and just don't forget to set the open level to our menu map in the game instance. Compile, save, and let's play. Click on Login, and here we go. Our login process with the account portal starts. Now we get an unverified application warning. To remove the warning, your application needs to be verified. For testing purposes, it's not necessary to rush the verification process. But if you want to start public testing, then you should go through the verification process. For now, just press Continue to App and allow. And here we are, logged into EOS and in our menu lobby with the player ID printed out in the corner. Success!